Welcome back. Mr. Sutton here, bringing you the Pre-Cal Honors 5-9 Part 2 homework solutions on quadratic trigonometric equations. For this quadratic trig equation, I see squared trig functions, non-squared trig functions. That tells me that I should probably just get everything on one side and see if I can factor this. So adding the sine squared over here, I have 2 sine squared of theta, and I'll subtract sine and keep the negative 1 over there. So this is what it looks like if I zero out this whole equation. Now I'm going to try to factor this. 2 sine squared, I'm going to have to split this up into 2 sine of theta and sine of theta. And I know I'm going to have a positive and a negative 1 also in my parentheses to get this negative 1 by multiplying. So let me just try this out with one combination. 2 sine of theta plus 1 and sine of theta minus 1. Let's just multiply this out and see if it gives us what we started with here. So we've got 2 sine times negative 1 is negative 2 sine. We have 1 times sine is positive 1 sine. Negative 2 plus 1 gives us this negative sine of theta in the middle. So this works out if you FOIL it out. Cool. Let's set each of these parentheses equal to 0 now and solve. For the first one, I subtract 1 and divide by 2. So I know that sine of theta then equals negative 1/2. And then for this other branch, sine is just going to equal positive 1 if I add 1 to the other side. There we go. And now over here, I see that my sine value is negative. That means that I'm wherever the y values are negative. That's below the x-axis in quadrants 3 and 4. Inverse sine of negative 1/2. I happen to know it's negative 30 degrees, but you could plug that into the calculator. The reference angle off this is going to be positive 30 degrees then, because we're 30 away from the x-axis. For quadrant 3, I need to do 180 plus my reference angle of 30. That's 210 degrees. For quadrant 4, I need to do 360 minus the reference angle of 30, giving me 330 degrees. So that's that first branch. Now, over this branch, I'm asking where's the sine equal to 1? Where is the y value of my angle equal to 1? There's only one place that happens, and that's at the top of the unit circle at 90 degrees. For this problem, I have multiple types of trig functions and this messy radical 2 to mess around with. It's tempting to divide by cosecant of theta, but I might be dividing by 0. I don't want to do that. Instead, I'm going to subtract things to one side or the other. Now, I have a choice of moving cosecant to the left or all this craziness to the right. I actually ended up moving all this over to the right, and you'll see why I did that. And then I wrote it on the left. So I have cosecant of theta minus all this garbage. And now I can factor out a cosecant. That's going to give me cosecant parentheses 1 minus radical 2 cosine of theta. All right, so now I'm going to set each of these equal to 0. So I've got cosecant equals 0. And if I subtract 1 and divide by negative radical 2, I have cosine of theta equals 1 over root 2. All right, let me go back to this cosecant branch now. Now we know we can't end here with cosecant equaling a number. We have to turn this into sine by taking the reciprocal of both sides. So I can write sine of theta equals 1 over 0. But this is a little bit of a problem because the sine of theta is now undefined. So that means that this is a dead end and it's not going to give us any answers. So hopefully we get something out of this branch. This can be written as radical 2 over 2 if I just simplify the radical. And the reason I'm doing that is this is a more recognizable special value of cosine. Let's figure out what quadrants we're in first, though. So this is a positive cosine. That means we're to the right of the y-axis in quadrants 1 and 4. And now the inverse cosine of radical 2 over 2, you might remember that the cosine of 45 degrees is root 2 over 2. 45 is a reference angle. It's also the quadrant 1 angle that we were looking for. So now we just have to find the quadrant 4 version of that. To get that, I'm just going to do 360 minus my reference angle of 45, which gives me 315 degrees. Now we're not quite done, because up here, notice they said we're solving for radians between 0 and 2 pi. 45, that's just pi over 4 radians. And 315 degrees, if you put that over 180 and reduce it, you'll eventually get 7 pi over 4 radians. To solve this trig equation, first I need to resist the urge to divide both sides by cosine, because cosine of theta might have a value of 0, and we don't want to divide by 0. Instead, I'm going to subtract cosine of theta to the left side, and now I can factor out cosine theta. So that's going to leave me with 2 cosine of theta minus 1 inside my parentheses. And now I'll set each of these factors equal to 0 and solve. So I can write cosine of theta equals 0, and setting this equal to 0, adding 1 and dividing by 2, we can say cosine of theta could also equal 1/2. Let's do the first branch here. Where does the x value of an angle, the cosine, equal 0? Well, that's when you're on the y-axis, so at the top and the bottom of the unit circle at 90 and 270 degrees. And we'll go back later and convert these to radians, but let's get all our other answers here. Now, over on this branch, I see that my cosine value is positive. That means I'm going to be on the right side of the y-axis in quadrants 1 and 4. So inverse cosine of 1/2. I happen to know that cosine of 60 is 1/2. This is already a reference angle, and it's also the quadrant 1 angle that we hope to find. To get my quadrant 4 angle, I just need to do 360 minus my reference angle of 60, which gives us 300 degrees. Now, before I forget, we need to go through and actually convert all these answers to radians. 90, that's going to be pi over 2. And I'm going to do exact answers with pi because I can. I don't need to round off unless I'm not going to get an exact answer here. 270, that's 3 pi over 2. 60, that's going to be pi over 3 if I do 60 over 180 with a pi on top. And then 300, that's going to be 5 pi over 3. For this problem, I need to solve this trig equation in radians. Now, since I've got 2 different types of trig functions, I'm just going to try to get everything over to one side and see if I can use factoring to sort of break these things apart. So let's start by subtracting cosine of theta. You can't divide by cosine of theta because it might have a value of 0. So subtracting and zeroing it out, I see that I have this common factor of cosine that I can factor out. So I can write cosine of theta and then parentheses tan of theta minus 1 equals 0. And now I have 2 factors that I can set equal to 0. So for one branch, I have cosine of theta equals 0. And for the other branch, setting this parentheses equal to 0, I have tan equals 1. All right, let's do this cosine branch. So basically we're asking here, where is the x value, the cosine, equal to 0? Well, that happens at the top of the unit circle and the bottom at 90 and 270 degrees. I'm going to do this in degrees first and convert to radians at the end. But now, since this trig function has, this trig equation has multiple trig functions in it, we have to double check and make sure the answers from one branch don't make the other branch undefined. So 90 and 270, is the tangent function okay with those? Well, it isn't, because tan is the slope of an angle, and the slope at 90 or 270 degrees is perfectly vertical, undefined. So since tan is undefined at 90 and 270, these are actually extraneous roots, and we're not going to bother converting them to radians because they don't count anyway. All right, this branch, we have a tan that's positive, meaning we're in quadrants 1 and 3 where the slope of the angle is positive. I happen to know that inverse tan of 1 is 45 degrees because tan of 45 equals 1. This is already a reference angle. It's the quadrant 1 angle that we wanted. I just have to find the quadrant 3 angle now. That's going to be 180 plus my reference angle of 45, which is 225 degrees. Not quite done, though. We have to convert these to radians. And since we could actually reduce these over a fraction with 180 in it, we can use just exact value, pi. So I'm going to convert this to pi over 4, and then this is going to be 5 pi over 4.